What did you say, Leah?
So at the end, because it's straight up.
At the end, because it's straight up and down. Think about what's straight up and down. What right against Texas? The screen, right? You're like just dropping straight down. Isn't that a lot steeper than even if it's something just like this, where it's like, you know, like very, very steep, something up and down, right? So to go at the very, very end. Okay? Everybody clear on that? Okay, so you will have to do that. Like I said, we got to put it in order from least to greatest or greatest to least. So you have to make sure, just like when you're ordering numbers, like when you were in kindergarten, you have to make sure that you're paying attention to what order that they wanted it. Okay? So any questions on that? Okay, if I can have one person from each group bring me the cards, I'm going to place them right here.
Every single day. So did it spell out anything?
It doesn't spell out anything. No, because then you are going to figure out what it spells, and then you're not even going to have to like look at the slopes. You're just going to try to, you know, figure out the riddle. So it doesn't spell anything.
You got random letters.
So that why did I put numbers? Letters. Because then I had it on order in my card how it already should be. So that it's just really easy for me to check. I don't even have to look at the slopes. You know, I can just look. Yeah. So I did that beforehand.
The mixed alphabet.
It's the alphabet. It doesn't make. It's the letters from the alphabet, but it's not in order like A through Z. Oh, I'm sorry, I missed phone there. Everybody have one? Okay, so wrapping everything up with what we are doing. Main thing, interpreting and locating all of these attributes of my graph. Okay, so let's start with Jack and Jill. Have a reader? You don't have what? Someone say you don't have it? Oh, did y'all say up a hill? Oh yeah, Jack and Jill up a hill. Okay, go ahead.
Jack and Jill each traveled for 3 hours at the rate described in the table below. Complete each table and write an equation for each driver showing the distance traveled in 30-minute intervals from 0 hours to 3 hours.
Okay. So we have Jack, we'll start with him. He drives his truck at 35 miles an hour. So I want to go ahead and fill out this table showing what it is for each time. So they want us to use the interval from 0 to 3. Okay? So then what intervals would we use to get there? Because what did it say? Traveled in what intervals? 30 minutes, right? So what would be the next number right here? 0.5, right? Because 0.5 is half an hour. Okay, they want 30-minute intervals. So what would be next? 1, 1.5, 2, 2.5. Okay? Independent variable time. Now, the distance traveled. When you have driven for 0 hours, what's my distance? 0. Okay? How about let's skip to 1. In 1 hour, how much have I traveled? 35. So then in 0.5 hours, half an hour, how much would I have traveled? 17.5. And how do you get that? Dividing 35 by 2 or 35 times what? 0.5, right? To get it. So now go ahead and fill out the rest of your table. What do we get for 1.5? 52.5. 2 hours? 2.5? And 3 hours?
105.
Okay, what would be an equation that would represent this situation? Formulate one with your group. What do we get?
Y equals 35x.
Why y equals 35x? Yes.
Because x is the number of hours and you travel 35 miles first and
X is the, yes, perfect, hours, and you multiply that by $35 each hour, which is my rate of change, right? Rate of change is also your what? Slope, it's in the slope position, and then the output would be my hours. Good? Okay. Jill, on the other hand, is traveling 55 miles an hour. Okay? And we want to know her same distance for the same amount of time. So 0.5, 1, 1.5, 2, 2.5, and 3. So we know at 0 it's 0, right? So at 0.5, what would she be?
27.5.
27.5. Go ahead and fill out the rest of the table. Okay, you hang on, what'd you get at 1?
27.5?
At what? I'm sorry?
55.
Okay, and continue at 1.5, what do we get?
82.5?
At 1.5?
82.5.
Okay. At 2?
137.5?
137? Yeah, because you should do 55 times 1, right? Is 55. Now 55 times 1.5 is what? You're reading 82. Okay. Then at 2 though, it's what? Okay. And at 3? I'm sorry, at 2.5, I skipped that. 2.5? 137.5, and then at 3? 165, perfect, okay? What's my equation? Y equals 55x, right? Because think about the operation that you were doing to get your outputs, right? You were multiplying everything in there by 55, right? Okay, now how does the distance traveled by Jack compare to the distance traveled by Jill? Look at the end of the 3 hours, okay? How do they compare? Regina?
Jill ended up driving more miles than Jack.
Everybody agree? Okay, and why do you think that is? Okay, perfect, right? So Jill drove more miles than Jack because she traveled at a faster rate, right? Always having to be able to justify why anything is happening, okay? Now graphically into another representation. It says graph the data for both drivers using a different color for each. You're going to use 2 colors, okay? Label each graph with its correct equation, and also label the axes and label the title for the graph. Okay, so let's start with the labeling first, because if we don't have that, then there's, we don't know what we're doing, okay? So what's the x-axis going to be labeled as? So time in hours, right? What's my y-axis going to be labeled as? Distance. Distance in miles. And what's a good title? Jack and Jill. Okay, Jack versus Jill. As long as it goes with it, okay? We don't want something like Halloween. It has nothing to do with Halloween, okay? Now, I want to know, what are my marks going by on my x-axis? What? I didn't hear you. Okay. What were they going by? 0.25, right? We noticed 0.25, 0.50, 0.75, 1, right? What are my y's going by? 10. It's very important that we're able to recognize that so we just don't think it's just 1, okay? So let's start with Jack. So we know that the lowest he has is 0, 0. And then instead of plotting every single point, let's just go ahead and graph at 3, where was he? 105, and then can we just connect those two together with your ruler, right? Wouldn't that save us more time than doing every single ordered pair there? So go to get you, now you can use your rulers and go and connect them. Okay, graph number 2 for Jill. Where do we start with Jill? The origin, right? And at 3, where did she end up though? 165, right? Oh yeah, 165. Make sure you have them in different colors and they're labeled with the equation. Okay. Now let's look at question number 1. It states, how does the graph of Jack's data compare to the graph of Jill's data? How does the graph compare? Just look at the graph. I don't care about the table anymore. I just want to know about the graph. How does Jack's data compare to Jill's? Allison, what do you think?
Well, they compare because Jill drove more than what Jack.
And how can you tell? So how did that affect it graphically? What's going on here? What do you see?
Well,